and welcome to the Basler Seminar Series presentation, Flexibility for Generator Fleets. Today's discussion will be led by Denny Raymond, Senior Application Engineer for Basler Electric. Denny has more than 15 years of experience in providing creative solutions in a variety of mission-critical systems. This session will last approximately 1 hour, and there'll be time following the presentation for questions and answers. Please use the Questions tab on the right-hand side of your screen to submit questions anytime throughout the presentation. And at the end, we'll get to as many of those as we can. If we're unable to answer your questions during the presentation, we'll follow up with you directly after the event. This event is also being recorded and will be available to view on demand using your event link. If you enjoy the session, please check out our events page on basler.com to keep up with everything that we have going on. And we also would like to encourage you to follow us on LinkedIn to stay informed of all of our other activities. With that, I will turn it over to Denny.
Thank you very much, TJ. My name is Denny Raymond, Application Engineer at Basler Electric, and today I am presenting on the topic Flexibility for Generator Fleets. Basler DGC controllers is the most reliable control solution for rental and military gensets. Basler Electric has multiple customers in this market, and some of them sell to rental fleet companies. The reason why they choose Basler is because with our solution, they can improve safety, avoid equipment damage, limit operational errors, which of course would lead to potential damage and safety incidents if the settings are not correct, if an operator is just changing settings at every instance when machines are moved around from one site to another. With our solution, operators can also reduce setup time and reduce power interruptions, and as a result, increase asset availability by keeping the power on when it's needed the most. And overall, rental fleet companies and operators can build a strong brand and reputation for their business using our solution. Why Basler? Well, we have a wealth of experience on our side, over 78 years of experience in the power systems business. And we have built a strong brand and reputation over those decades. We build a high quality product. If you've ever used a Basler product, you will see the Basler name and logo on it. And we're a family owned company and have been since inception. And if your name was on something, I am sure that you would have with the ownership of this company, the Basler. They have continued for a very long time to ensure a high level of quality that we deliver to our customers. And with our solution, you can achieve total system control with voltage regulation, protective relays, genset control, paralleling gear, and so on and so forth. So we're a multifaceted solution, and that's what we provide. And the rental fleet generator market is just one of those areas where we provide that expertise. So Basler, being a leader in technology and innovation, we were the first to develop a solid state voltage regulator, and also the first to develop a microprocessor-based voltage regulator. In addition to that, we were also the first to develop the solid state protective relay. We're in multiple countries and with a strong reputation all over the world for many, many years. When it comes to the control of genset fleets, there are some key requirements that a controller needs to meet. And I'm going to dive deeper into each of these four, but just to list them here at the beginning of the presentation. Number one, adaptability to changing power requirements. As generators are moved from one site to another, the power requirements change. That means the voltage may change, the frequency may change. It may be three-phase at one site, single-phase at another site. And it is important to have a controller that is able to adapt to these changing conditions. Also, the ability to be plug and play. Communications and networking are a key part of control activities in today's world. And it's just so important to have devices that can plug and play into each other as well as into other devices. Redundant communications. Well, if you have a communications failure, it is important to have a seamless method of having a backup so that you can basically hot swap communication ports on the fly without human interference and keep the operation running. And a product that is robust to withstand harsh environments, because rental and military generators that are usually put in fleets, they can be in any environment. They're very often in outdoor environments, so it's a non-controlled environment, and you need a controller that is robust enough to withstand these kinds of harsh environments. So first, let's delve a little deeper into requirement number one, which is the adaptability to changing power requirements. So right here on the left, I am showing a picture of a portable generator mounted on a trailer. So you've probably seen these kinds of generators at entertainment venues, construction sites. You'll see them at a military base and so on and so forth. So these kinds of portable generators are typically moved from one site to another. And it is important as they get moved for the operators and owners to be able to quickly disassemble these generators, mobilize them, and set them up to operate at a different site and meet all the requirements to ensure a seamless, effective, and safe operation every time these generators are moved from one site to another. And one way that we accommodate all of that is via on-the-fly settings changes. So we can take logic conditions and detect certain things about the generator's operation to make on-the-fly settings adjustments to allow control and protection for variable voltages, various frequencies as well. So the Basler advantage when it comes to generator fleets is, number one, the ability to avoid operational errors. If a person is changing settings every single time a machine is moved around, then at one point in time, it is likely that you may have someone making an operational error, and that can cause a safety incident. So then we improve safety by avoiding having to make these operational changes repeatedly, and as a result, a potential operational error. So you can avoid this using our solution. And if you avoid errors, you avoid safety incidents, then you can increase equipment uptime, you increase the running time of the generator, and whatever the generator is powering, whatever loads, whatever machinery and equipment that generator is providing electricity for, you improve and increase the equipment uptime for that asset. And overall, you build a strong reputation for your business. So as far as multiple voltage configurations go, you may have seen a selector switch on a generator that looks somewhat like this. This is just one example showing some typical voltages here in the continental United States that you will see configurable machines being switched to. So the way this works is you have a 12 lead machine typically, and you can connect the leads in series or in parallel. And when the leads are connected in series, this is called the series or high Y configuration. And that is typically 480 volts line to line, 270 volts line to neutral. Then you have the parallel or the low Y configuration, which is basically half that voltage. That would be 240 volts line to line or 139 volts line to neutral. Now, typically 208 line to line, 120 line to neutral is used. And the way that is done is to let the machine run in the parallel Y configuration and then use the voltage regulator to dial the voltage down to 200. I'll take single phase configurations like a series zigzag or parallel zigzag that can get you anywhere from maybe 240 or 120. So using a select switch, you're basically reconnecting the windings of the generator to determine what the output is going to be. And at any given point in time, that machine could be operating at 480, 277, 240, 139, and you can use the voltage regulator to dial that down to 208, 120, which is what we see more commonly, or it could be a single phase configuration, either 240 or 120 volts. Besides voltage flexibility, we offer more flexibility. Some generators need to operate at 60 hertz in some instances, and in other applications at 50 hertz. If that generator is moved from one country to another, in some countries, the grid operates at 60 hertz. In some countries, it operates at 50 hertz. Multiple fuel types. So not only diesel, all standby generators operate on natural gas, some on liquefied petroleum gas, some operate on multiple fuels. For example, there are natural gas generators that have a pressure switch that senses the pressure gas, and if the pressure drops below a threshold, then there's a solenoid valve that changes position to allow LPG to fuel the generator so that the generator never needs to stop operating. So for all these various fuel configurations, we have a control solution that can support that. So Adaptive control is a key requirement to effective genset control for fleets where the generators move around from site to site. And in the case of voltage and frequency, it's important to be able to automatically adjust the parameters according to the voltage and frequency that's selected for the machine to operate in at any given point in time. And some of these control settings that are key include the generator ratings, as well as the bus ratings, generator stability detection. So in Basler lingo, we define stability of the generator as basically within a certain window of rated frequency and voltage. So the key parameters for stability are voltage and frequency, and these must be within a certain window right around rated. So for example, 60 hertz, 480 within a certain bandwidth. Only then the generator is considered stable, and same for the bus. It must be somewhere close to its rated voltage and frequency. And breaker control as well can be affected by this. For example, active synchronization. The synchronizer does not become active until both the gen and the bus are determined to be stable by the controller. And if a machine is being synchronized to a bus, then a breaker close request will not be sent until a sync breaker close OK status is achieved, because you can't close a breaker to a live bus unless the generator and the bus are matched, right? So that covers your 25A and your 25, and also load sharing, because first the two machines need to be synchronized before they can load share. So all these operations and more are impacted by the ability of the controller to perform adaptive control, and that's why this is so important. So let's delve a bit deeper into variable voltage operation to understand how we can achieve that with a Basler solution. There are three methods that I'm going to go through. First, method number one is simply assigning contact inputs. Within the programmable input settings on the Basler controllers, there is a programmable functions page, and these are preset programmable functions that can simply be mapped to a contact input. The DGC 2020 and the DGC 2020 HD each have 16 contact inputs. Any one of these inputs can be mapped to any one of these programmable functions. The two programmable functions we will look at are the low line override programmable function and the single phase override programmable function. So in this example I am showing here, input number one is mapped to low line override. What that means is as soon as input one closes, then the controller will be given a low line override status. That means the controller will determine that the machine is operating in a low Y configuration. So if it's a 480 volt machine, once input one is closed, the controller now sees the machine as a 240 volt machine, and it updates its control and protection settings accordingly. Similarly, for the single phase override, input two as my input of choice. As long as input two is closed, then the controller is given a single phase override status. The assumption here is that a free phase configuration is the normal configuration, and the alternate configuration is a single phase configuration. As soon as input two closes, the controller basically switches over from three-phase operation to single phase operation. A contact is considered closed when it is switched directly to battery negative. So as long as that direct contact is made between contact input one and battery negative, it's considered closed, and the controller will be given a low line override status. And similarly, once input two is closed, it will be given a single phase override status. So method one is that simple. It's simply just a matter of selecting a few settings. Method two involves the implementation of some very simple logic. So it also entails using contact inputs. So input one would need to close to set the low line override logic element. You're doing the same thing, but you're just using the programmable function or a logic test. So you can choose to use logic and map input one to the low line override logic element and map input two to the single phase override logic element. So I've done the same thing, just using two different methods. And again, you can use any one of 16 inputs to do this. I've just chosen input one for low line override and input two for single phase override. Method three is very different. It does not involve any IO or logic. Method 3 is simply the controller's ability to automatically detect the configuration of the machine. There are just a few settings that need to be entered in order to achieve this. And first, the enable setting here needs to be enabled to enable this feature. And then we have to have a single phase detection threshold and a low line detection threshold. The single phase detection threshold of 100 volts here means that if the delta between any two phases is 100 volts or greater, the controller will determine that the machine is in a single phase configuration. And the detection threshold of 300 volts here means that if the controller senses a generator voltage of 300 volts or below, it's going to determine that the machine is operating in a low Y configuration. So for example, if the normal voltage for the machine is 480 volts, you stop the machine, which of course you always have to shut down the machine before you reconfigure the voltage or the frequency. And then you turn that selector switch to low Y, and it's now operating at 208, 120. The machine starts running and the controller senses that the voltage is below 300 volts. It's going to determine that the machine is in a low Y configuration and update all settings, such as control and protection settings, to accommodate that low Y configuration. It's going to give itself a low line override status, pretty much. So that was voltage. Now let's talk about frequency. For alternate frequency detection, there aren't as many different ways to do this, but there's still a very simple way to do it. So again, you need to use a contact input, and that could be any one of 16 contact inputs. I've chosen to use input 16 to set the override element. Whenever that input, so in this case, input 16, whenever it's closed, meaning it's switched directly to ground or battery negative, then the alternate frequency override logic element is set, and the controller now adopts whatever that alternate frequency is. And this is where you set that. So the assumption is that the rated frequency of the unit is 60 hertz and the alternate frequency is 50 hertz. So whatever frequency is entered here in this alternate frequency setting space right here, this is the frequency that the controller is going to assume once the alternate frequency override logic element is set. So we've talked about control. We also need to talk about protection. With this ability to configure and automatically detect and automatically update protection and control settings, you can accommodate all machine configurations. And a lot of that is done by selecting or deselecting protective elements based on logic conditions. And operators can save a lot of time that would be spent making settings changes when power requirements change, as we mentioned before, and you can avoid errors. Protection is very important because you can have a machine fail or have the customer's equipment fail, or worse yet, have a safety incident if the machine is not protected correctly. Catastrophic things can happen, and you want to make sure that you have proper protection in place to ensure a safe and smooth operation. So let's talk about voltage protection as offered by the DDC 2020 HD, and then we'll look at the DDC 2020. In the DDC 2020 HD, there are 6 over voltage and 6 under voltage protection elements. So your 59 is over voltage, 27 is under voltage. And each of these elements comprises a 3-phase set of settings and a single phase set of settings. So the way you would do this for a 480 volt machine is to enable both 3-phase and single phase modes, and your source will be generator for both, and just set the same pickup level. So let's say you want the pickup, which is the threshold for over voltage, to be 10% overrated. Then you can just enter 1.1 in this per unit box, and the pickup level automatically updates to 528 volts, which is 10% above 480. And you do the same for single phase. And you can increase the activation delay. By default, it's 0.1 seconds, which is very fast. So you can increase that a little bit to about 1 second or so, whatever is convenient for the application. And the alarm configuration, it does not have to be an alarm. An alarm will open the breaker and shut down the machine as long as that time activation delay has expired. However, it can be a pre-alarm, which can be used as a warning, or it can just be a status. Now, a key setting here is the low line scale factor. Right here in this box, I have 0.43. As soon as the controller determines that the machine is operating in a low Y configuration, then all the voltage protection settings get multiplied by 8, because the machine in that case would be running at 208 volts. In the case of single phase, let's say that the single phase voltage is 120 volts. Then you would apply both the single phase override and the low line scale factor as well. So then once the single phase override logic element is set, then the controller is given this, and the single phase protection elements are now active. So although they're both enabled in logic, only one is active at any given point in time. By default, the 3-phase settings are active, and if the single phase override logic element is active, then the single phase settings are active. And you also would give the controller a low line override status, and change the scale factor to 0.25, because 120 over 480, that's 0.25. And now all the settings get multiplied. This threshold pickup gets multiplied by 0.25, and that would give you protection at 132 volts for your pickup, which is 10% over 120. So with just one settings element, your 59-1, you have already implemented protection for 3 different voltage configurations, for high Y, low Y, and single phase. And you would do the same for the 27, the under voltage. You can do the same with the 2020 HD. Just use one element for 3 different voltage configurations. And then you can have multiple 59 elements and multiple 27s. You can have one as a pre-alarm, another as an alarm, and set different thresholds like a high, 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 and so on and so forth. In the case of the DGC 2020, things are a little different. You need to use multiple elements to achieve that. There are 2 under voltage protection elements and 2 over voltage protection elements in the DGC 2020. So the way you would do that is to first select the 59-1 elements, for example, for the high Y case, and then select the 59-2 elements for the low Y case. And you would enter the settings accordingly. So here for your 59-1, that's your high Y case, you would enter a pickup of 528 volts or 1.1 per unit. And then for 59-2, you would enter 10% above 208 as your pickup setting for your 59-2, and similar for the 27-1 and 27-2. And here's your logic scheme. So the algorithm is going to read something like, if a high Y configuration is detected, then block the protection settings that apply to the low Y configuration. Else, block the protection settings that apply to the high Y configuration. So basically, you're blocking one set of settings at any given point in time. You're letting one set of settings be unblocked while you block the other. So here, if you have a low line input, if the status input is true, which it will be true if the controller has a low line override status, then you block the high Y case and you unblock the settings that apply to the low Y configuration, so that these protection settings will be active and these will not be active. And then the logic just flips for the high Y case. For alternate frequency protection, there is an alternate frequency scale factor in the DGC 2020 as well as the 2020 HD. And this scale factor is found down here where it says alternate frequency scale factor. So if the rated frequency of the machine, nominally it's 60 hertz, but the alternate frequency is 50 hertz, then you just take 50 divided by 60, that yields 0.833, and use that as your alternate frequency scale factor. So you would set your protective element, your 81-1, and you can set the mode for over or under, and there are several other modes. But let's say this one is set for over, and your pickup is 62 hertz for a 60 hertz machine. And then you can set your activation delay, inhibit voltages, and so on. And your alternate scale factor now is when the controller determines that it's given, the machine is operating at the alternate frequency, then it takes the alternate scale factor and uses that as a multiplier to change the pickup level. So now your frequency protection is going to be set up for a 50 hertz scenario once that alternate frequency scale factor is applied. And again, you can set the alarm configuration to an alarm, a pre-alarm, a status, an alarm with cooldown, alarm with unload and cooldown, etc. Okay, let's move on to the next requirement, which is plug and play communications. So in today's world of technology and advanced communications, genset controllers also participate in Ethernet communications, I guess the Internet of Things, building management systems, and so on and so forth. Now, one thing we've done is to use Ethernet communications also for load sharing. So many manufacturers do this differently, but that's one of the ways in which we're differentiated. And it's so much advantageous to use Ethernet communications because of the speeds and the plug and play capability of it. Now, there are two ways you can do Ethernet communications, and you can use static IPs or automatic configuration, and we can accommodate both. So in the case of static IPs, it's okay if you have a small group of generators, maybe just 2, 3 or 4 generators. HD, you can have up to 32 generators. Then it becomes time consuming and tedious to enter static IP addresses for every single controller and ensuring that the default gateway and subnet mask settings are correct, because all the controllers need to be on the same subnet. And that's important to ensure that they're all part of the same segment and they can load share properly and perform all the other activities that take place on our inter-genset communications network. So that can be tedious and it can become difficult to track. So you take 5 machines out of one fleet and put them into another fleet. Then what if the IP settings don't match the subnets that existing fleet has as its setting? And it becomes difficult to track and could be difficult to manage. So our solution for that is to use automatic configuration. If you think about it, when you buy a communications device, whether it's a laptop PC or a smartphone, and you walk into your house and you connect to your Wi-Fi network, you don't go in and set a static IP address. The network assigns an IP address to your new device. So similarly, you can check this DHCP box right here. And what that does is it enables automatic configuration so that the network assigns an IP address to your controller once you plug it into the network. And another really neat feature that we provide is the ability to scan the network and view serial numbers and assign IP addresses and how they correspond with each other. So there's a button you can press when you're connecting to a new controller, once you're establishing a new connection. And that button allows you to scan the network, and you're going to see a list of all controllers on the network with the serial number matching the IP address. Because you didn't enter those IP addresses, the network assigned the IP address. So if you want to know which controller has what IP address, you can do a scan to determine that. So that saves time. It improves the ease of setup. It just makes things simpler and avoids potential erroneous settings. Another key requirement that we listed was redundant Ethernet communications. And so like I said, we use Ethernet for load sharing, and that Ethernet network forms the backbone of a lot of the advanced features of the DGC 2020 HD controller, including broadcast logic and just some more advanced communications that we use that for. So here, each DGC 2020 HD is shown having 2 Ethernet ports. And the idea is if an Ethernet port fails, then what do, right? So there's a second Ethernet port that can be used as a backup. And as shown in this drawing here, if there's a link between these 2 Ethernet switches, then you form the ring network, and you can swap back and forth between Ethernet port 2 and Ethernet port 1 on each controller and have continued communications where Ethernet port 2 is a backup to Ethernet port 1 in the event that it fails. So you can have this done 2 ways, where Ethernet ports 1 and 2 are on separate independent networks, which is the default setting. If this redundant Ethernet box is unchecked, that's the case. So as you see here in the grayed out boxes, I have very different IP settings for Ethernet port 2, 169.254.1.1, whereas Ethernet port 1 has a 10.0.1.10. So very different, they're on different subnets altogether. And this would be an example where maybe you're using Ethernet port 1 for load sharing and you're using Ethernet port 2 for Modbus communications to a separate system. Or you can check the redundant Ethernet port box, use Ethernet port 1 for everything, including load sharing, including Modbus communications to an external device, because it's capable of doing all of that. And in that case, Ethernet port 2 just becomes a failover to Ethernet port 1 in the event of a comms failure. So Ethernet port 2 in this case, because the redundant Ethernet box is checked, has adopted the settings of Ethernet port 1, and it's on standby as a failover port. So communications will switch over to Ethernet port 2 if a failure is detected on Ethernet port 1, and load sharing, Modbus communications, and everything else that this Ethernet port is being used for can continue seamlessly in the event of a failure. Well, of course, a communications failure on an Ethernet port has to be detected somehow, and we have two methods of doing that. The first is the link monitor. What the link monitor does is it just monitors whether there's an unbroken link anywhere, and if there's an unbroken link to any Ethernet port, then it's going to determine that a comms failure has occurred, and it's going to enunciate that as a pre-alarm. The second method is called the ARP ping method. And you can have up to 16 IP addresses entered here, but the controller sends out a ping to the network. And if it doesn't get a response, then it determines that there has been a comms failure. So these are your two methods: the link monitor that just determines whether there's a broken link, and then the ARP ping mode that sends out a ping and waits for a response. And if it doesn't get a response, it determines that a failure has occurred. Regardless which of these methods is being used, you can set up a ring network that is very robust to communications failures. And the way you would do that is to assign an Ethernet switch to each controller, but you use both Ethernet ports. So if Ethernet port 1 on each controller is going to its switch, as shown here, so Ethernet port 3, but then the alternate Ethernet port has to go to a different switch, as shown here. So Ethernet port 2 on controller 1 goes to switch 2. Well, this sort of network is very robust to many different types of failures. For example, in this case, we have 4 failures. Every line that's covered with a red X indicates a failed line. So here, Ethernet port 1 has failed, but we still have a healthy port on Ethernet port 2. And we have continued communications throughout the network. We've lost another link here, we've lost a link here, and we've also lost the link between Ethernet switches 1 and 3. But despite all of that, we still have a healthy network, and we can continue to have inter-genset comm between controllers 1, 2, and 3, which means that load sharing continues seamlessly, Modbus communications, and all other inter-genset comms activities continue seamlessly. Here's another failure example. This one is a failed Ethernet switch, but because of the ring network, Ethernet switches 1 and 3 are still connected, so you have a continuous path of communication from controller 1 through Ethernet switch 1 through Ethernet switch 3 to controller 3, and also Ethernet switch 3 is connected to controller 2. So you still have a clear communication path between controllers 1, 2, and 3. It doesn't matter if Ethernet port 1 is active on controller 1 and Ethernet port 2 is active on controller 2. The system doesn't really care as long as there's a clear communication path. So you can have, some controllers using Ethernet port 2 as the active port, whereas some controllers using Ethernet port 1 as the active port at a given point in time, and communications continue seamlessly. Just one final example of another communications failure that this setup will withstand: links that are broken between Ethernet switches 1 and 2 and 2 and 3. In that case, you still have an unbroken link between Ethernet switch 1 and Ethernet switch 3. So you have a clear communication path here through Ethernet switch 1, going back through 3 to controller 3 and to controller 2 as well. And lastly, we'd like to talk just a little bit about the need for a controller to be robust to withstand harsh environments in a rental fleet. So here's your DGC product line, the DGC 2020 HD to the left, and then the 2020 in the middle, and the DGC 2020 ES on the right. So the 2020 HD is your advanced paralleling controller, and the DGC 2020 really today used for standalone generators as well as the DGC 2020 ES, and the 2020 ES used for simpler applications, really for emergency standby. So throughout this entire suite of products, you're going to find that one of these controllers is the right one for your rental fleet application. But all of them share something in common, and that is they are built to last. They are built in a very robust fashion, and they're tested extensively to ensure durability in the field. One of the ways in which we ensure that level of durability is using this potted design. This is a picture of the back of a DGC 2020, and you can see this potting here that holds all the electronic components together. So that gives the controller the ability to be able to withstand harsh vibrations as well as shock conditions, in addition to high temperatures as well as low temperatures. And you can see the temperature ranges here, and humidity and salt spray and all these kinds of harsh elements that come in uncontrolled environments, such as dust ingression, for example. So these controllers can withstand outdoor environments, and really that's what you want for a rental fleet, because you don't know exactly where the generators will be throughout their operating lifetime. And to add to that level of robustness and reliability, we offer a top mount enclosure that can easily be mounted on top of the generator terminal box as shown in this picture. So the controller will come mounted and wired as shown here in this picture in the middle. The terminal box has, the enclosure has a DC terminal strip on the bottom and an AC terminal strip on the top. So all the installer needs to do is to bring in a wiring harness and just terminate the wires on the necessary DC and AC terminals. So this is a very neat solution. It's a NEMA foil enclosure, and it is built to withstand vibration, shock, and high temperatures in various harsh environments. Here's a list of just some agency approvals that we have across the product line: CE, UL, CSA, NFPA, ABS, and EAC. Some of these apply to not all of the products, but at least one of them. But the technical bulletin will give you the specifics for that product. So in summary, we're saying that the successful operation of a generator fleet requires that genset controllers meet 4 major criteria: that they're adaptable to changing power requirements, such as changing voltages, frequencies, and fuel types; that they're plug-and-play communications devices, and we achieve that by having RJ45 ports on the controllers themselves, the DGC 2020 HD specifically, to just allow you to use jumper Ethernet cables to connect them to each other, as well as to an Ethernet switch to some event of a failure, just to more robustness to the system. And controllers that are built to withstand harsh environments as well, because the generators can change owners, they can move from one environment to the other, and they'll often be in uncontrolled environments. So our genset controllers effectively control and protect generators in various configurations, as we have demonstrated. And operators can save time and improve reliability by eliminating the need for making settings adjustments when generators are moved to a different site. This is done on the fly at initial setup. You set up the controllers so that they can take status inputs and automatically update settings to effectively control and protect the machine regardless of what the operating configuration is. We have a white paper that was recently published on this subject. It is titled Flexible Control for Generator Fleets. And the idea here is to enable operators and assemblers to build a versatile fleet of backup generators for any application. This white paper is available for download on the DGC 2020 HD, and I believe also the DGC 2020 product page. You can reach out to our tech support group or myself to obtain this white paper. And also, there is an application note associated with it that gets into the details of how to set up control and protection for configurable machines that operate at various voltage and frequencies. So some of the examples I illustrated today, you're going to see some similar examples and more detail in that application note. So be sure to download the application note if you'd like to learn more on this subject. And lastly, we are tremendously good at technical support, both from the point of view of our tech support team. We are 24/7, 365, local in the United States. One company supporting all the power systems products, from protective relays to voltage regulators to excitation systems to DGC controllers. And you get direct access to the technical experts to get a direct answer. We're a big little company because while we're so big that we can manufacture and design and support our own products, but yet we're small enough to the extent that we know the people who actually design the products and we can get direct answers from them. And we have quick response times as well. That is something we have done for a long time and continue to do. From the point of view of resources, our instruction manuals are available for download on our website. And all you need is an account with Basler.com. And you can download instruction manuals, application notes, application guides, and logic libraries. The application guides and logic libraries are a recent addition. They are available. There are 3 that are available for the DGC 2020 HD for some common applications, as well as 1 that's available for the DGC 2020, and there will be more to come. And there are also some technical papers. So we published 2 white papers on the DGC 2020 and how it can be used in various applications this year, and one of which is on this topic, flexibility for generator fleets. Our software is free, and that is a big plus. There's no license, there are no fees. There's an account with Basler.com. And once you have that account, you can download BestComms Plus, which is the software that is used to configure our genset controllers. We also have retrofit options, and there is a cheat sheet available. So if you have a legacy DGC controller, you can use a DGC 2020 in various style numbers to replace that controller. And of course, multiple troubleshooting tools, a lot of which are embedded into the BestComms Plus software, such as our analysis plots and sequence of events reporting, and so on and so forth. There are just so many troubleshooting and diagnostic tools that are available to you to help you do an effective job. So with that, I hope that you have enjoyed this presentation and you found it helpful and informative. And at this time, I will take any questions.
Yeah, it looks like we've got a few questions here already. First one is, how is frequency changed in a DGC controller?
Okay, so typically you would have the rated frequency of the machine. And in a US-based application, that would be 60 hertz. And then you need to have the alternate frequency setting. So let us say your alternate frequency is 50 hertz. Then there is an alternate frequency override logic element. And that logic element needs to be set. So you need to use an input to set that alternate frequency override logic element. Let's say you use a contact input. So if you're using a selector switch to change over the frequency selection of the machine from 60 hertz to 50 hertz, when that switch switches over to 50 hertz, then that switch position needs to close contact that you've mapped to set the alternate frequency override logic element. So let's say you've chosen contact input 3 to set that logic element. When your switch on your generator switches over to 50 hertz, then that position needs to close contact input 3, and the closure of contact input 3 is going to set your alternate frequency override logic element, and the controller will then determine that the machine is operating at 50 hertz, and it will automatically adjust the control and protection settings by the alternate frequency scale factor.
Okay, next question. What is a low line scale factor?
Do we have some more questions?
Sorry, it may have broken up. We'll repeat the question. What is a low line scale factor?
Okay, it is just a multiplier that is used to determine by what factor mathematically the settings for voltage should be multiplied by. So for example, if you have a protection setting of pickup for overvoltage for 528 volts, and now the machine is operating in a low Y configuration, let's say it's operating at 208 volts, then you take that 208 and divide it by 480, that gives you a scale factor of 0.43. So you also want your overvoltage protection to be multiplied by that same scale factor. That's your low line scale factor. So once that low line override status is given to the controller, it's going to apply that low line scale factor of 0.43 and adjust the overvoltage protection threshold by that much. So it's going to come down to somewhere above 208, maybe 240 or somewhere there.
Okay. Next question. What is a ring network?
A ring network. Okay. So a ring network in I guess Ethernet networking, it's really a closed loop network where every device, the ring is really between the switches. So every device is connected to at least two other devices. There's no device that's connected to only one device. And because every device is connected to at least two other devices, if there's one broken link, then you still have every device on the network. So if you think of a circle with many points around it, then every point, every node on that circle is connected to at least two other nodes. And if you have one open link due to a failure, then you can still have continued communications throughout that network.
Okay, next question. How many I/O pins are available and what other specific contacts like Watchdog?
The DDC 2020 and 2020 HD have 16 contact inputs and 12 contact outputs each. You can get additional I/O, modules to increase the level of I/O, digital as well as analog, but I think we're talking about digital. So we manufacture and offer contact expansion modules. Each DDC 2020 can accommodate up to one contact expansion module, and each DDC 2020 HD can accommodate up to 4 contact expansion modules. And each contact expansion module gives you several additional digital inputs and outputs. So if you're in an application where the controller itself does not have enough onboard I/O, then you can certainly consider using expansion modules to increase the amount of I/O to give you what you need.
Okay, next question. What are the benefits of Ethernet genset communications, and is it necessary for generator fleets?
Sure. So the benefits include speed, being plug and play. It's faster than, for example, CAN bus in terms of the amount of megabytes per second that you can transmit. In addition to that, you can have more reliability because with Ethernet, you can have more topologies. CAN bus is a bus, so it's a bus topology. With Ethernet, you can have more topologies, like you can build a ring network, as I illustrated, using switches. You can also have a mesh topology, and ring on mesh topologies are known to be more reliable than bus topologies or even star topologies. With a star topology, if you lose the central node, then the entire network is knocked out, and you don't want that. But with a ring or a mesh topology, then you can continue to have the rest of the network function if one node is lost. And for generator fleets, this is really good because you don't want the entire fleet of generators out of operation because one node is lost or because of something that happened on a CAN bus network and it took out an entire trunk line or an entire stub. You want to have more flexibility as far as building a robust network and giving yourself more options for more topologies and being able to reconfigure that in ways that will limit, risk to the network. So faster transmission rates, more topologies, lower risk of failure, and then redundant communications and the ability to be plug and play. Because if an operator is running a rental fleet in a remote environment, it is very likely that they'll want to monitor the performance and operation of the fleet, and their customer might want to do that as well. We live in a time where people want a lot of data, and they want to monitor everything that's going on. And to be able to do that, you somehow most times need to get on some type of Ethernet network. And the fact that the controllers already come with onboard RJ45 connectors, then you can simply just plug and play into an external network for that.
All right. Are there any disadvantages of using expansion modules? I think I'll repeat.
Well, the I/O available on the controller. Yeah, so if you don't need to use an expansion module, it's certainly advantageous to just use the I/O that's available on the controller. However, if it needs to be used, then that would certainly be the way to go. But then you'd be certainly introducing another potential point of, well, I don't want to say a point of failure, but it's just another node, another piece of equipment that's in there. So that's something to bear in mind. And the contact closures closing times are different for the CEMs versus the controller itself. So it depends on how critical the application is, but the contacts are gold contacts. Some of the contacts in the CEM are gold contacts, so it helps to alleviate that potential issue as well.
Okay, I think that wraps us up for the day. Thank you, Denny. Great job. Thank you, everyone, for joining us, and we look forward to seeing you at our next event.